So activation function. So what this activation function is, so like as we have discussed, so we have some values here, right? So previously, like I'm starting with the single example what we had before, -1, and this is your weights, and with that you have a bias here, let's call it like 1. And what we did is a kind of a function which it will check, is it greater than or equal to 2, something like this, right? So but while you are using, there are few standard active, so this function where we are actually checking the output and finally giving a true or false. Here in this case it's a true or false. It can be continuous as well. There are few functions where it can give a continuous function as well. So that we call it like activation function. So it means your cell get fired only in case of it meets this condition, right? So till then it will give 0. Only in case if this meets, it gives 1, right? So in that kind of scenario, what you do is, like you will actually see like there can be different functions. So instead of this greater than or equal to 2, I'm keeping it as f of x. Okay, so rest all the same. So I'm keeping it f of x and then seeing it. So what you can see is like your y will be like, here it is w plus b, right? So w plus b. So in that I am actually passing that one to an f of x, and this function will return you whether your output. Okay, so what function it can have is like this f of x what we wrote here. This function, we can call it as an activation function, and this function can, one of those, there are like many functions for this. So one of them is well known to us, like sigmoid. So this sigmoid, what it can do is something like this. So if we have seen that, right? So instead of giving just a 0 or 1 here, so it will give you a continuous value. So it value of it will be like this. Okay, I did not draw it properly. So let me draw it. Okay, I just will move this axis here. Okay, it's slightly okay. Like what will have is a midpoint here, where at 0.5 it will intersect here, and then this is 0, and you have values here, positive values and negative values. So for your values, if your value is greater than 0.5, okay, so or your value x is like greater than 0, it can give you, sorry, like your x is greater than 0, it will give you output like this is your f of x and this is your x. So if your x is greater than 0, depending on your x value, it will give you some value. Okay, so and this curve we can write it as 1 by e plus e power x. Okay, so this is your function. So what we have is here, instead of greater than or equal to 2, we can have it like this. So what will happen is when x equal to 0, it will give 1 by 1 plus e power 0, which is 1 by 1 plus 1, which is 1 by 2, which is 0.5. Okay, similarly when x is lesser value, okay, some -10 or something, it will calculate the value here and it will give you some value here. So that value will be some 0.2 or something like this. So similarly for plus 10, it will calculate e power 10 and it will give you some value. Okay, so this is how it is done. Okay, -10, this will go to +10 because like it is -6. So it will give to something like 0.8 or something. So this will be your output function from the, in case if you use a sigmoid. So this will be a continuous function, and also it's something kind of what you can say, like it's a probability, right? So we use it, like mostly we use sigmoid for probability, or we can also call it like a softmax. So with a slightly different scenario, we have made a video regarding that as well before. So apart from that, so let me talk about like one more function which was similar to this, Relu. So what Relu will do is, so it is slightly a different function. So where your value, when it is greater than 0, it will be giving the same value. when it is less than 0, it will just give 0. Means f of x equal to x if f x greater than 0 and equal to 0 if x less than or equal to 0. Okay, so this is how like Relu function works. So taking this, just that when your value is positive here, so it will return the same value or the, when it is like negative value here or 0, it will return you 0. Okay, so that's how like the Relu function works. And like we'll anyway come into like, there are like many other functions just to discuss, like I mentioned these two. Similarly, there is tan h function and many others. Okay, so we'll anyway make a separate session discussing about like what are the activation functions available and like what are the advantages, when to use what, and so on. So that in the later stages, but as of now, think about this. So what it will do is these functions f dash x, like what we have here, right? So if you go forward, these f2 dash, like f3 dash, what these are these functions. So these are those functions. Okay, so this is how like activation functions will work. Now you have the complete component of like, we have discussed all the components of a neural network. Now we are good to design our own neural network and try with an example like